A very good evening to one and all. Welcome back to our channel, Maths with Khader sir. As you know, we completed the exercise problems of chapter Real Numbers, exercise 1.1. Now we are moving to example sums which are after exercise problems. Now the first example is example 5, that is prove root 3 is irrational. Root 3 is irrational. You proved in the last video the root 2 is irrational. Same as root 2, the root 3 also. So to prove anything in the mathematics, we go against of the statement. So let root 3 is rational. So you know that the rational form is p by q, and q is not equals to 0, and p comma q are co-primes. That means having only the common factor 1. So root 3 is equals to p by q. Now squaring on both sides to remove the square. Root 3 whole square is equals to p by q whole square. 3 is equals to p square by q square. Now take this q this side and 3 to this side. That is what? P square by 3. This is 1. Where the 3 dividing p square. We have theorem 1.2, that is, if any prime number divides a natural number square, that means it divides that number also. So if 3 divides p square, it divides p also. So take p is equals to 3r. So take p is equals to 3r. Now substitute the value p in the equation 1. Q square is equals to p square by 3. P square by 3, where p is 3r whole square. 3 is equals to 9r square by 3. In 3 table 9 3 times 3r square q square. So if you observe here, q square is equals to 3r square. This is 2. Where the p is dividing both p square and where the 3 dividing q. That means it dividing both p and q. But what is our condition? P and q are co-primes, having only one as prime factor. But here we have another number also. So our assumption is wrong. Our assumption is wrong. Therefore root 3 is irrational. So this is how we have to prove the irrationality of any number.